All right, so we're getting ready to start our unit on solution chemistry. And most of solutions that we are going to discuss involve water. And so it would be really helpful for us to review properties of water that we already know. So if we think back to chapter 6, where we talked about molecular structure, let's review what we know. If I'm talking about water, whose formula is H2O, I would think that we're at a stage where we would recognize that oxygen is going to be our central atom because it needs the most number of bonds. And so oxygen is actually going to have 2 bonds. And so that means the 4 other valence electrons are going to be involved in non-bonding. So we have 2 non-bonding pairs in oxygen. Those non-bonding pairs are going to put those hydrogens at an angle because they occupy more space and have a greater repulsion. So you probably recall that water has a bent shape, sometimes known as angular. Now, you also may recall that we talked about the polarity of a molecule. So oxygen has a higher electronegativity, so we would assign it a partial negative charge. And the hydrogens in each bond would have the lower electronegativity, so they would be assigned a partial positive charge. So we drew dipoles. So remember that dipoles point in the direction of the more electronegative element. And because water has polar bonds that are at an angle, they don't cancel out. So not only does this molecule have polar bonds, but the molecule itself is polar. Now, also in this chapter, we discussed intermolecular forces, so the forces that occur between molecules. So these dashed lines that are in this picture are representing the intermolecular force for water. And you may remember that water has hydrogen bonding. Okay. So hydrogen bonding is a special type of dipole-dipole force, and it occurs when you have hydrogen bonded to a highly electronegative element. In this case, the highly electronegative element is oxygen. Now, because water has this hydrogen bond, we actually see some unique characteristics of water. So let's look at those. So one of the things we notice about water is that it has the ability to occur in all 3 states of matter on Earth. So if I'm looking at this, we can clearly see the solid version of water, which is ice, on top of that pond or lake. Okay. And we know that underneath that ice layer, we're going to have the liquid version, so water. And then even though we can't see it because it's colorless, in the atmosphere, we have water vapor. All right, let's talk about another unique characteristic of water. So if I'm looking at my picture here, I have a lake, and you can see that it's frozen over. But you can also see that we have aquatic life underneath that ice layer. And that's because ice floats. So we have enough chemistry experience or even science knowledge to know that it floats because ice is less dense than liquid water. All right, so let's look at the formation of ice then. All right. So ice consists of water molecules in a hexagonal arrangement. That's what we see in the picture. Now, the importance of this hexagonal arrangement is that we can clearly see in the picture that there are open spaces between water molecules. Okay, so let's talk about how these open spaces are going to affect our density. So we know density is going to be equal to the mass divided by the volume. Those open spaces is going to cause an increase in the volume. And so when you take the mass and divide it by a larger number, the density then goes down. So that open space between those water molecules is what accounts for ice being less dense than liquid water.